Here are the answers for the section 9-8 homework, starting with the oral. We're asked to solve the equation, but without using any calculator or anything. So to do this, let's apply the theorem from the section. When you have a regular number being multiplied in front of a logarithm, that number can be repositioned to become an exponent on the argument of the log. So on the right side of this equation, we can think of it as log of 5 squared. And then if that's equal to log of n, we can see that the n has to equal 5 squared, which is 25. For number 2, we can approach it in the same way. On the right side of the equation, instead of writing 3 times a logarithm, we can take that coefficient of 3 and make it be an exponent on the argument of the logarithm. So the right side is log base 5 of 2 to the third power. And if that's equal to this over here, we can see that the n has to be 2 to the third power, which is 8. For number 3, let's do that same technique. On the right side, we write it as log base 7 of 36 to the 1/2 power. Well, 36 to the 1/2 power is 6, and so n is equal to 6. Number 4, we can condense this as log of 8 to the 1/3. And if that's equal to the log of n, then the n has to be 8 to the 1/3. But 8 to the 1/3 is 2. Number 5, on the left side, we can write it as log of n to the 3rd. And if that's equal to the log of 125, we can see that n to the 3rd has to be 125. Therefore, n is equal to 5. Number 6, on the left side, we can write it as log base 8 of n squared. On the right side, we have log base 8 of 49. So therefore, n squared is equal to 49. Solving for n by doing the positive and negative square root, we get plus or minus 7. For the written, we're still solving equations, so let's make use of our condensing techniques that we've learned over the last 2 sections. When you have a difference of logarithms, you can condense using a single logarithm. A difference changes into division of the arguments, and that's equal to 2. Now let's solve the logarithm by exponentiating. Take the base of the log, raise it to the 2nd power, and that's equal to n over 4. So we have 9 is equal to n over 4, therefore 36 is equal to n. Number 24, we can condense the left side. Log of 9x times x, and that's equal to 4. So we have the log of 9x squared is equal to 4. To solve a logarithm equation, you exponentiate. What's the base of this log? It's a 10. So we have 10 to the 4th power is equal to 9x squared. This means that 9x squared is equal to 10,000. We can divide by 9 on both sides, getting 10,000 over 9. And then take the positive and negative square root of that. The square root of 10,000 is 100, and the square root of 9 is 3. Number 26, let's condense on the left side. A difference changes into division of the arguments. Now that we have the same style of logarithm on both sides, we can equate our arguments. And then solve this equation. First step, times the m to the right side. Then subtract m from both sides. And divide by 3. Number 28, let's condense on the left side. This has an adding, so that means you multiply the arguments. Six to the 1st power is equal to y minus 3 times y plus 2. Let's do FOIL on the right side. We have y squared minus y minus 6 is equal to 6. Because this is quadratic, let's get it equal to 0. And we can solve using factoring. Y equals 4 or negative 3. Number 30, let's condense on the left side. When this is a subtraction, you create division in your arguments. Now solve the logarithmic equation by exponentiating. The base of the log is 3. So 3 to the negative 2 is equal to the 2v minus 5 over v squared plus 4v plus 4. 3 to the negative 2 is 1/9. Now we need to solve this equation, but this has the look of a proportion. We can use the cross multiplication technique. 1 times the v squared plus 4v plus 4 is equal to the 9 times the 2v minus 5. That's 18v minus 45. This is quadratic because highest degree 2, so let's make standard form. Subtract the 18v and add the 45. We can solve this using factoring. This is v minus 7 squared is equal to 0. Take the square root of both sides, and we get that v is equal to 7. On page 351, we were evaluating logarithms using our calculator. So push the log button, and then input 3760. If you round it, the answer is about 3.575. To do anti-log, the button on our calculator says 10 to the x on it. And the answer is 2,630.26. For number 12, we're asked to solve the equation. And the equation has powers on both sides, but luckily the powers have the same base. Therefore, the exponents must be equal. This creates a quadratic equation, so let's make standard form. We can solve this with factoring, completing the square, quadratic formula, or graphing method. Let's try factoring. Then we can solve for n. In the first group of parentheses, we get negative 1/3. In the second set of parentheses, n is 2. For number 16, we have an equation with powers, but this time we don't have the same base. Let's rewrite 125 as 5 to the 3rd power. And rewrite 625 as 5 to the 4th power. Then use the rule about multiplying those exponents. Now that we have the same base, we can equate our exponents. 6v minus 3 is equal to 4v. Subtract the 4v and add the 3, then divide by the 2. For number 22, we're asked to graph this exponential function. It has an adjustment of -2 on the end, so the horizontal asymptote line, instead of the x-axis, has been shifted down 2 spots. I've drawn that in green ink. Now make an xy table. When x is 0, what's y? 3 to the 0 makes 1. 1 take away 2 is -1. What about when x is 1? 3 to the 1 is 3. 3 take away 2 is 1. What about when x is 2? 3 to the 2 is 9. 9 take away 2 is 7. Let's do a -1 for x. 3 to the -1 is 1/3. 1/3 take away 2 makes -1 and 2/3. This is probably enough to graph. So left 1, down 1 and 2/3. Then 0, -1, 1, 1, and 2, 7. Start right along that horizontal asymptote and then swing up through the dots.